Hello again. So in this video we're going to be tackling the repair of this vise. Now I've just been given this vise and I've got a screw for it over here, but it's a record number 23 and the jaws are 4 1/4 inches wide and it's overall 17 inches long. Now I was quite happy to get this vise because I've been looking for another big vise for quite a while to go on one of my other workbenches. Now there's one little thing wrong with this one. If you look there, where the guide is, it's actually been welded because it's broken off, and the weld underneath has really good penetration, but over here it's quite, well, the penetration's alright, but you can see it looks quite bad. And I've been at it with a chipping hammer and I can't seem to break a great deal off. Now I didn't weld this, but I think the weld underneath is very structurally sound. I have no problem with that, but this weld just looks a bit ugly, so I'm going to grind all this weld back and try to blend it in with the original radii of the vise. But there is one major problem with this vise, and some of you may have already noticed that this jaw sits lower than the fixed jaw, and when we lift it up they realign with each other again. And that's because when the guide's been welded on, it's been welded on lower. And we can also tell this by looking underneath where it's all been ground away with an angle grinder. Now it's sitting on just a piece of scrap wood, so I can keep the bench clean at the moment, because it's been sitting under a welding bench, I presume, for a very, very long time. So how I propose to fix it is if we remove the moving jaw, there are two pads there which it slides on. Now if we're going to return the jaws to height, we're going to need to raise it using these two pads. So you can see them there. And I've previously lifted it up and I've seen there's about a 1/16 of an inch difference. So this is some hot rolled 1/16 of an inch plate, the correct width for the pads. So what I propose is I'll clean all this down, I'll drill and tap 2 holes in each side, then I'll drill and countersink corresponding holes in the plate. So I'll have 2 plates there and there made out of this, so that the 2 jaws will then line up, so then I can continue using it here in the workshop. So the 2 holes in the vise I'll drill on the drilling machine, and the holes in the plate I'll do on the milling machine, so I know they're quite accurate. Now I could probably get this in the milling machine, but it'd take quite a while to set up, and as long as the layout's pretty accurate, I think I'll be okay. So I've just gone over the pads with a small scraper, just to clean some of the accumulated dirt off them. Now to lay it out, I'm going to use this, which is a scribing tool with a carbide scribe and then like a vernier scale on it. And it's got a roller there, so you just slide backwards and forwards to scribe a line. So if you want it from this face, you put the roller on the face and slide it forwards. So this is the setup at the drilling machine. So I've got the vise body held down with 2 bolts to the round table of my drilling machine. Then I'm going to centre drill and drill the holes I've just shown in the photo being marked out. So I've got the drill running at the slowest speed, and always slide sleeves up when using the machine, and wear safety glasses. So now I've drilled the hole. Here's a quick tip for when tapping with a small tap into something like a casting. Having a tap break would be pretty disastrous. So if you take the drill out of the chuck without moving anything on the machine, and then take your tapered tap and then place it in the chuck, but only tighten it with your fingers, then bring it down to the hole, and then use the chuck key in the hole just to turn the chuck until the tap stops turning. Then lift the quill away, and you know you have a squarely started tap. Now you could power tap, but this is a very, very small tap. It'll break quite easily, but most importantly this drill doesn't really spin slow enough and doesn't really have a quick reverse time either. So this is my setup on my small milling machine. So this has got a 28-inch table, and the camera's about halfway down. So I'm going to centre drill and drill one hole, and then using the graduations move 10mm along that way. Just drill another one here. Now they're going to be drilled the clearance size for 4BA, which is the size of screw I'm using. And this little mill's only got a small quill, so for using the drill I'm going to have to lift the head up. So now you unlock the head with a small lever on the side, and then there's a hand wheel on the top which will retract the head. So now I've cranked 10mm that direction. I can take the drill out and put the centre drill back in. But then I've obviously got to crank the head back down. Now my mill does make quite a bit of noise, and that's because it's still driven by the original 4-speed gearbox, because this mill is an X1LP. So effectively you have a 28-inch table, standard X1 head but with a big motor on it, but you also have a lot more travel in the XZ axis. The Y axis is the same. And now I just need to countersink the holes, because when there's a countersunk headed screw sitting in them, I want this to be the top surface, not the heads of the screws. So as a countersink I've got this, which is an old centre drill that's been reground with a tool post grinder, and that's because the angle on the end of the screws is quite a strange angle, and I didn't have a proper countersink in that size. So if I take the drill out, then we'll crank the head back down, and then can sink these holes. Now, this small mill has quite a strange quill, whereby the quill moves the whole head down, so that the actual piece on the column stays still, but the motor unit is actually all mounted on the quill, which means you only have a very small quill. But unlike the X2, the head's actually on a screw, not on a rack. And then just bring the head down and lock it in position. There we go, and then lock the head. Now, because this cutter's going to be cutting on quite a large surface, I'll run the mill quite slow. I do just tend to leave it in the lowest speed anyway. And I'll countersink the other one off camera. So now that's the repair finished. So the jaws now line up very flat, which means the vise will now open and close very nicely. The only thing left to do is I still don't have quick release on this vise. The lever's just there, but doesn't actually do anything. And I've been underneath, and the nut's still there. And I've found this piece of bar, which I'm going to make the pusher for the nut with. Thank you very much for watching, and once I've ground all the weld off and painted it, I'll put some photos on the end of another video.